So yes, the first person today is Jerome Martinez, I think, showing us raw cooked. And do we have Jerome online?
Yes, I am there.
Oh, there you are. Sorry. And well, go ahead, Jerome.
Okay. So, not yet. We will focus with a tool called RawCooked on a specific need. It is about DPX. DPX are difficult. It is one file per image, and there is a WAV file usually for the audio. And for storage, it is huge, big because it is uncompressed. And usually we want to keep the DPX without any recompression because we want to keep everything from the content, no lossy compression. And also sometimes there is some commitment to keep the DPX as they are. So we cannot just compress with a lossless compression tool and then say, okay, you have a file, just a lossless compressed file, but we don't have any more the DPX. So for resolving this issue, we have a tool called RawCooked. When we compress the files, the DPX files, and we create one file. It is a Matroska for the container and FFV1 for the video, but we also keep the DPX header in order to revert to the DPX when it is needed. So it is just a command line version for the moment. So we will check the command line, RawCooked, for example, and yeah, we have this here. We have DPX sequence in the iPres dataset. We have 6 files, 1, 2, 3, 4, 5, 6 DPX. Usually you have thousands of files because with a 1 hour of content, you have 3060 seconds, twice 24, 25, or 30 images. This, we have just an example with 6 files, but we will see what we can do with it. RawCooked on the directory. Let's see that. Yes, I'm with -all. We will compress it. And now if we check everything, we have different files. We have 6 files here, more than 1 megabyte each. So the directory is 7 megabytes. And when we compress, we have 2 megabytes of content. So for these 6 files, the compression is very good. If we check with, for example, media info, I will see the DPX there. It is just basic DPX, small ones. And we have a Matroska file compressed in FFV1 lossless compression. So we can see the count of seconds we have and so on. It is a small one there. So it is good, but the idea behind that is to be able to revert to DPX, not just having compressed file. We can do with RawCooked on the MKV file, the compressed file. We revert, so now we have another directory, so the decompressed file with the same directory name, with the same file name. And if we check the MD5, for example, up here, return it. It started by 9.2, and the source file is exactly same, 9.2 and so on. So we have we compress, then decompress it. And we usually have a 50% compression. Here it is a bit more because it is a synthetic file. But usually it is 50% compression, and you have no more thousands of files. When you you put it on your LTO, you have only one file. So it is a lot better. And if you have petabytes of content, having a gain of 50% when you buy your LTO, it is maybe good. We are also able with Rocook to check the MD5 if there is some content. In the backoff dataset, there was no MD5, so we will create one. For example, that. So we have the MD5 file, the basic one. The previous one. So now, if we check everything with a dash dash all, it will active the check of hashes. So we have still the same, but we have another information that file hashes were found. So it is used for checking. So if the MD5 is wrong, for example, if we edit it, we create a bug, an issue. If we do that, we say, oh, this is not confirming because out6.dpx is wrong. The hash is not good. So before we compress, we warn that there is an issue with the package. There is an MD5 file and it is wrong. So let's stop that. Now we have a Matroska file. Still, we can store it, we can transfer it to someone else, and then with Rocooked we can check that the file is healthy with Rocooked-check. And we check the file, we check compared to the hashes, we store the hashes of the decompressed file. We try to decompress and we check that everything is fine. Here it is fine, but we can also, if we don't have hashes, or the MD5 file, we also can compare to the input. For example, there. It will compare the decompressed content to the initial content. So, for example, if we modify a file, for example, so let's say that your storage is not good, we change a byte, crazy byte, there, we can detect it. There is a problem. So it is detected that the file is not as expected. So we have a lot of things for checking that the content is healthy, that we can recreate the TPX, but also that everything is fine. We have different options, so we can do some conformance checking about the DPX files. It is still on progress, so we do a basic conformance checking for the moment. We have also, as I said, we can compute the hashes, the MD5 hashes. If it is not done, we can compare to the current MD5 also. And there is a help, very classic man Rocooked. And we can have different options about where to store the content. Here it is the output name. We can have also a different option to say yes, we want to automatically say yes to every prompt or no, so it is used for automation. We have different actions, so like check, a quick check also, or if you want no check at all. DPX may have some padding bits, so we can also check them. Or if we want to avoid some speed impact, we can avoid to check paddings. We can check the coherency of a file. If we can check, for example, if you have files 1, 2, 3, 4, and 7, files 5 and 6 are missing, we can detect that. And there is maybe a problem in your DPX package. And conch is a conformance check of the file. And we can decode or encode. This is what we saw. We can compute hashes. We can compute frame MD5 directly. So frame MD5 is not MD5 of the file. It is MD5 of the outputted content when it is decoded. And we can accept gaps, or we can reject when there is gap in the file name. I said 1, 2, 3, 4, up 6. The file 5.dpx is missing. We can accept or not accept that. That's all for me. So if you have questions.
Thank you very much, Jerome. Round of applause. Make sure I don't get scared again when the egg timer always startles me when it goes off. But thank you very much. So let's do some jury feedback first. I can start. That was a nice presentation. I think what it also showcased is how many levels of checksum exist for AV. It's not just files. You can go down to frames and even go down from slices to there. I come from, there it is again. I come from an institution that actively uses frame MD5s. We have a digitization vendor who produces DPXs, do the migration for us. And we have used Rockhook to actually prove lossless migration that they did when they converted it to Matroshka. So it's a great tool. That is all from me right now. I would hand over to Kieran.
Yeah, raw cooked is something very special. I think it's been incorporated by a lot of national film archives and probably smaller ones as well. DPX sequences, you know, having 130,000 files for just one work or one representation within your archive is tough. So just having a single NKV, which makes this file smaller, and it's totally reversible, like a zip file. It's pretty wonderful, and it's been an amazing contribution to audiovisual preservation. So.
That was a great live demo, thank you. And also really liked at the end that you showcased all the different functions. So yeah, cool.
So, great demo. It's really refreshing to see a command line demo again after all after all the UIs. We should do more from them because we need to show people it's not that hard to use a command line. It's like using the mouse. You have to remember, and there is always help. And the other thing I wanted to comment, great name of the tool. That's very great planning. I had planning to be part of this. I think this gives you an extra point here in the scoreboard.
Some people are command line lovers, right? But a GUI is planned also in the future when we have some free time, because some people are afraid about the command line. So for a first step, we plan to have a GUI for that. Something I forgot to say is that it is about DPX at the start, but now we support also TIFF and EXR and compressed.
That is great. That is great to know. So the audience doesn't look too scared yet. I know you can't see them, but do they have any questions for Jerome? There's one.
Hi, Lucy from the BFI. It's not a question, it's just more an outpouring of love, and just as Jerome knows, it's for us, having raw cooked is such a game changer, and it just has really transformed the way that we preserve our DPXs, and they're just smaller, more accessible, easier to handle, and that just has, you know, an effect further down in terms of cost of storage and size of storage and all of that. And it's just, if you have DPXs in your collection, I cannot recommend raw cooked more, and it's just fabulous. So just from the BFI especially, Jerome, thank you so much, and keep going. Thank you.
Thank you.
Any other questions, comments?
Yeah, what kind of compression do you use? Is it based on 7-zip or is it proprietary?
The compression is usually between 1/3 and 2/3 of initial content, and with an average of 50% in every archive.
But only,
The compression depends a lot on the kind of content you have.
but is it based
No.
on something existing, or did you develop something new, a new compression?
No, we use an open source and IETF standardized format called FFV1.
Okay,
So it is playable by VLC, for example, or FFmpeg, and so on. So every tool based on FFmpeg is able to play it. So it is only six frames. So it is difficult to show something, but if we open the file in VLC, for example, we see that it is just a standard file. So it is only 6 frames, so it is not easy to see. But for VLC, it is just a normal file. So the compression format is not our format. It is a very IETF standard.
Actually, I have one additional question for you. You said that you store the DPX header metadata as well. So if you create an MKV and then go back to recreate the DPX, does the metadata get inserted back into the DPX correctly?
The DPX is exactly same. So if you check the MD5 of the files, so here we have, let's check so here, in this part, it is the MD5 of the input. Now we go to the output file created by Rocooked for the export. And if we do the checksum, they are exactly same. So they are, there is the MD5. But if you check out one, they have the same MD5. So we keep the DPX header and we compress ourselves with a zip. But all the headers are stored, so we can, when we uncompress, we store, we create exactly the same output file than the input. So it is really like a zip. It is not just taking the content and lossless compression of the content. It is lossless compression of the content, but also lossless compression of the metadata.
Thank you very much. I think that's it, all the time that we have for questions right now. Just want to say that recently we made a joke at an AV conference. Media Area is such a household name there. If we would turn your tool, name dropping of your tool into a drinking game at an AV preservation conference, everyone would be hammered by noon, I think. Thank you very much, Jerome. Another round of applause. And we're moving back to on-site demos, and next is Tobias showcasing game preservation.
Okay. Hi, everybody. 8 years ago, I took a sabbatical from digital preservation, and I went a few months to Paris to get trained as a cook, as a chef in classic French cuisine, and that's the first presentation I can do about digital preservation with all the kitchen lingo that I learned at that time. I didn't write up for the dessert. I'm a chef. I'm a cook. I'm a chef. I don't know anything about pastry, about desserts, about making gelati and so on. But you put me into the food truck. That's where I feel comfortable. And you all know the food truck kitchens. They're very small, very narrow. And what's the basic thing that you need in a small kitchen? It's a chef's knife and it's a heat source, a fire or a stove or something. And that's the two things I want to use today. So I'm part of the ICA expert groups on archival description. That's the group that developing the new records and context standard to describe archival content. So my tools are a text editor, that's the knife, And the heat source, that's two ontologies. That's the new records in context ontology, and that's the premise ontology, because I learned that you can impress the jury by using premise. Here, that's the link to the records in context ontology. You can't cook everything at once in the food truck. You have to decide, and I decided to take the CD-ROM from 1997. That's arcade game, classic games, 100 games on one CD. So it should be sufficient. It's a great pleasure after 2 years cooking for 4 persons in my family, all at once cooking for 80 people. That's how I feel comfortable in a real kitchen. So I tried to show how to cook one of these games. That's a game that was published in 1978. That's a remake from 1995. It's called Space Invaders. In parallel, published with other games who looked more or less the same. You know all these kinds of games. So here it's emulated on an emulator called DOSBox. The game was written for DOS, and DOS is based on a certain CPU or processor infrastructure or architecture, x86. And here I'm running it on a Macintosh, so it's an emulation. It's not just a virtual machine on the same architecture. So what I did to archive this small game, and games are complicated, so they need a whole environment to get them running. That's the one thing. But then from a cultural perspective, games are not just an executable files, but games were delivered on a CD-ROM, on a floppy disk. They have a box with nice images. They have a manual, a printed manual. There were magazines published to review these games. If you go a bit later on, if you at the time you had networked games, you had a whole community, how to emulate the community, and so on and so forth. So we have a whole network that we need to describe and to contextualize a game. And ontologies and linked data are very good tools to contextualize computer games and to archive them. So what I did is I started my text editor, and I started to describe this CD-ROM. That's in the lingo of records in context. It's a record set. It has a title. It has a date. It has a publisher, an agent. If I go down, this agent is described somewhere. It's a publishing house, Data Becker, a German publishing house which existed until 2014. What do we have else? And then I have a link to another record, to an item, which I find here, record number 2. That's the Space Out Invader. That's the name of the game. This game is included on this CD-ROM. It has an author. This author is described as an agent. It has a publishing date, 1995. What is really important if you're archiving games are all the information about rules and regulations. Who has the copyrights? Until when is the copyright enforced? When does it go into public domain, and so on. So you need all this information, especially if you're not doing it at home for your private use, but if you're an institution that wants to publish things. And this game has an instantiation, and now we drill down into in the language of premise. It's a representation. I go down here to this representation. I have an executable. This is not only one file, it's several files, but I pack it into one file just to demonstrate it. And it's stored at somewhere, and it has characteristics. So that's the good thing. So now I'm turning from the descriptive metadata in RICO, I'm turning down into the technical metadata from premise, and I'm start to describe characteristics of this, of what is needed to run this game. But first, let me go to the file. I have a file, an exe file that I need to run, that's the program of the file. This has a fixity, a checksum, and so on. It has a size. And now I'm not only describing metadata, but I'm putting the whole content into my text file. So here I say this has content. The content of the file I encode it in a base 64 stream, in the base 64, how do you say? Yeah, byte stream. Base 64 you all need all day because the attachments of the emails are encoded in base 64, and you send them, and then the recipient decodes them and can read the file. So I encode my executable file as a text string. It's much larger than this one. It's 400 kilobytes, so that's a much larger string. And I store this inside this. And then now we go down to the environments. So my file needs a certain environment to run. That's all written on the CD here in the small print. It's described. I need a Windows 95 operating system. Windows 95 runs on x86 processor, on the x86 processor family. I need a graphic card with 256 colors, a CD-ROM, a mouse. So that's the main requirements to run the game. So we have the byte stream, we have the description of what is needed, and then we can start up our Windows 95 environment and start mount the CD here, mount the game, and get it running. But just before I want to run the game, I want to show you something else. Oops. So I want to visualize what I have written in my text file. So I load this text file into a GraphDB. GraphDB is just nice to visualize such networks. So I have my CD here with all the description. I have this record number 2. This is my game. My game has a representation here, which is the executable file, and then I have here the file itself, and the file itself has the content. So that's the in one text file, and I can visualize it in a graph. That's the complete archiving of my small game. So we're ready and can be served. And the last thing, to come back to the kitchen, the last thing, I think that's a showcase how records in context and premise, they match perfectly. So I don't know if you know how to make mayonnaise. You take egg yolk, you take oil, and you beat them up to have a nice not emulation, but emulsion. But emulsion, and I think that it shows if you take two things together, 1 + 1 is not 2, but it's 3 or 4, and you get something completely new. Thank you.
Thomas, thank you. Tobias, thank you so much. I'm always delighted to see someone presenting something about emulation. And I think this is a very important work. There's still, I think, a long way to go. Yeah. I think that there are two issues. We can discuss this later. One is, can you actually, when you prepared this this year, this is all handmade, or
this is all hand. This is all written by hand. but I can deduct the options for my DOS emulator and start the DOS emulator from the metadata.
Oh, that's
It's not easy or something like this elaborated platform, that's for sure. But it's just as a use case, I can start the emulator, mount the file, and start the emulator. Yeah.
Yes, but the creation of the meal as you did it by hand, so it's a great effort. So thank you very much doing that for this session.
Yeah, it was lovely to see a practical example of linked data, and also that you highlighted how complex games can be, because it's not only the files but also the whole context around them. So yeah, well done. And I also very appreciated all the cooking puns. Yeah.
Yeah, of course you win my heart if you mention premise, that's right. And video games. So yeah, very, very lovely. I think you're really hitting one of the big gaps that I think we have in making emulation work, and also in how we as libraries and archives currently approach the huge CD-ROM collections and so forth that we have, because they're not at all described the way that we need them to be described to make emulation work or to make preservation work. So I really appreciate the fact that you've mapped that and showed a way how that information could be captured. I think after we're done, we might give you a minute to start up the game, just so you can see, so we can all marvel at the food. But I'll hand over to Kieran first.
Yeah.
Yeah, it's great because it was my first time actually seeing records in context, like properly as well. And also, I'm always been really interested in environmental information and capturing that in premise environments. But I think that's actually one of the nicest implementations of it I've seen. And it's just, I guess, premise wrapped up in records in context. So that was quite lovely. So yeah, I guess if there is time to boot up, that'd be great.
Because we want to see it actually works, right?
Yeah. So here's the CD. I start the program. Here I have the space games, and it's too many. I'm looking for SOI. So that's the game, and I started. PLBM. That's a small company that obviously still exists. So, and that's the game. Oh, I only have the sound here locally. So it's very simple. It's not even. Yeah, it's the basically the game mechanics that you had at the end of the 1970s in arcade game, redone, reprogrammed in another language in 1995, and even the sound is not even a polyphonic synthesizer. So also the sound very. But obviously, this guy has produced this game in his spare time. So there's very few information about the author, and you see how, yeah, such hobbyist projects are hard to document, yeah, in a way this is community work and community archiving as well, as we heard this morning, and these are things that are just disappearing.
Thank you very much. Are there questions for Tobias? Ross?
Thanks, Kieran. I think Frank said if I really want to be seen on camera, I have to stand just behind that pillar. I'll try and make a question out of this. I don't want to do that bad habit of making a comment.
Can also do a comment.
I appreciate it. I really appreciate the sentiment of all you need is a knife and a heat source, and I think there's something to be said about the simplicity of the approach here. I guess to extend the cooking metaphor, I feel like maybe, and this is where it becomes a question, this could be the vegan, dairy-free, meat-free dish, if in fact records in context results in a lower profile in terms of amount of bytes used to store metadata kind of profile. But for some of the more complex examples you've been modeling using RIC, are you finding perhaps less lines of text being used and less storage space being used for the kind of apes being created?
I have the impression that that with this combination of premise and RIC, you need much less space than using METs. I come from a world where we used METs, EAD, and premise, and you have such long metadata files, so that it was really hard to work on these XML files. And I have the impression that already just moving to an RDF world, it compresses already. You have much more information and much less gray space. Already, this is the first space or step. And then in records in context, you can decide how much information do you want to pack into. So you can keep records in context very, very simple, not more complicated than doubling core, for example, or you can make it very elaborate for your one-star Michelin dish if you want. So that's really up to the institution and up to the use case. And that's one design principle for EGAT that is really important, so that also small institutions who want just to encode the bare minimum of metadata, that they can also use records in context. There's not even a minimum of metadata prescribed that it's a valid records in context file or something.
I'm just giving Kieran some exercise. Thank you. I'm always absolutely delighted seeing RIC being implemented in practice, and looking forward to seeing version 1 finally come out. To continue the analogy of cooking, are there any existing ready meals using RIC? How does it integrate into existing systems, maybe? And how could we implement it in existing systems?
Well, we saw Libnova before the break, and that was really, I was really impressed. So that you either can choose, obviously, do you want to visualize your migrated file in a program, in an actual program that you have on your computer, or do you want to start an emulator and watch at your original file in the emulator? And that was a really beautiful solution that I thought. And yesterday, the two presentations about emulation, really impressive how far these projects went. One has not to forget that most of these emulators are produced by hobbyists. They are not paid for that. But these emulators are very far, at least for the most common platforms, not for some exotic video game consoles from Japan in the 1980s, just before Nintendo came and so on. That's harder to find, but the mainstream hardware architecture, you find emulators, software emulators. And you start also to find quite cheap hardware emulators where you can emulate the real hardware and run so you can program the processor to work as an Amiga or as an Atari processor.
Yes, thank you.
Thank you very much. If it's not beyond your French culinary education.
Oh, I love wooden spoons. Yes. That's perfect. Thank you very much.
Round of applause for Tobias. And next we have Michel. I'm sorry, I did it again wrong. Presenting the DocByte platform.
Yes. Hi all. So as DocByte, a bit back to maybe the all-you-can-eat session. So we deliver a platform where we created a platform really with the archivist in mind, but we try to cohere to all the specifications, all the possibilities there, but also to legislations. There's a whole set of legislations coming up in regards to archiving, and that's what we want to play in. So at first I loaded a few of the items that were in the pantry in the archive, but of course it's a demo, so I selected 3 of them out of it as well, and I'll run just an ingest on that. So what I'm doing here is I'm just going through the files on the file system, and I'm creating small zips, no pre-ingests being run on it, putting some metadata with the file name and the files next to it. So we ingest those, and I'll have a look. Yeah. The internet connection isn't that great, so they are already all ingested because it were, of course, only 3, so we can follow up on the package ingestion, but we can also browse through the archive, and we see here, so I created, we have a file plan structure that we built based off metadata. So I created also the metadata of the folder structure where they were, and we see here that there was the iPres breakoff, and so the different files have been loaded in that. I'm just going to do a small refresh so that it loads the full set. What I've done is, so I selected a PDF from it. What we can see is really a representation of the package. We use the eArc package specification. So this is a representation of an eArc AIP, and you will recognize the terms being used in there. So we have the representation, and we have metadata on the package level. We have our Dublin Core XML, so everything is stored in XMLs and visualized with XSLTs, so it's very easy to configure for extra visualizations. And if we go into the representation, we can see, of course, the document itself if we have a web browserable version available, but we can also see all the metadata of that representation. And there I get the extra points for mentioning premise. So there we have our premise file that we keep with all the events that happened on it. And during ingest, already quite some events have happened on this. And we can see some of that also reflected in the other metadata where we have used Apache Tika to do some characterization, but we also used Vera PDF to do validations on the PDF file. We've used Droid to do identification, format identification, so the format is logged into the premise file as well. So that's all here. Very basic, creating an archive and setting up the whole thing, but how do we make that legally compliant? Well, then we have just one other file that needs to load, which takes a bit more processing. Well, there was one file in there which contained a digital signature. And digital signatures are very good and very useful for us because we can start working digitally with everything, and we have some way to sign things. But digital signatures have an expiration date, where a paper signature does not. A digital signature has an expiration date, and it means that after that expiration date, or even before, if something goes wrong with the certificate, that signature can no longer be proven as being valid. So what we did here, it was a portfolio file with some attachments, so I extracted those attachments separately, and if we go look into this PDF file, it contained a signature, and we have run the full PDF signature validation on it. This can be done for PDF files, but can also be done for XADA signatures, CADA signatures,
all kinds of things. And we store actually, this is the visual report, but we also have the technical report and the symbolized visual report. So we store those reports of that validation, which allows us to prove, okay, at the moment that this document arrived in the system, that signature was valid. Although here it was not valid, small remark, even Adobe is saying that this signature is valid. If you do a full correct validation on it, it's not. So we have the report saying, okay, this signature was valid at a moment in time, but of course that report can also be forged. So in order to extend on that, what we are doing is using timestamping to prove the existence of everything in our AIP. We generate the checksums, we put them together in a Merkle tree, and we add a timestamp on that, and that we can see here in the evidences part. In the evidence, we see the moment of timestamping, we see the expiration of timestamping, but because also those timestamps can expire. So what we are doing in the system is that actually we can track those expiries of those timestamps, and we can enhance upon them every time that it's necessary in order to create a new timestamp that proves that that whole set of the document, the validation of the signature, and everything around it is still valid after time. What we've also done, and that's one other that I've shown here, what we also do is, of course, from the other ingest steps, migrations, format migrations. So here I have configured that the Word document needs to be also converted into a PDF file. If we look in the PDF, we see the document and we also see all the premise events that happened with the transformation engine, with everything. Transformation engine, we are using DocShifter, and that's actually a sister company of DocByte, which we started as a product, but has now split off as a full document transformation platform, actually. Of course, during the time of your archives, things can change. So how we do this all is actually based on a plugin system. No, quickly, no, wrong file. So based on a plugin system, we actually run all these plugins. So for each type of validation, migration, those kind of things, we have a plugin, and we can run those on the whole set or on some selected AIPs. So if we do run plugin here, we can actually select PDF validation, fixity information validation, or calculation if it's not yet available. So those are all run on ingest, but we can also rerun them. And for instance, if I run the timestamping plugin, it will re-timestamp the whole set so that we can keep that. Next to that, we of course have the mandatory pie charts. And we go further in other things. Also, for instance, if I still have the time, we can also, 1 minute, no. We can also attach retention on the items, legal hold, full sets of those requirements as well. There you go.
Thank you. Sorry, I didn't catch your name. Is it Michiel?
Yeah.
Oh, so fellow Dutchie. Extra bonus points there.
Belgium.
Belgium. Okay, good enough. Yeah. But yeah, it was great. Thank you. And what I especially really liked about it, the interface is great, but also that you take into consideration that there's a changing nature to a lot of our institutions and to legislation. So yeah, great. Thank you.
Yeah.
Great presentation. what I liked in particular was the dealing with the certificates, dealing with or working with certificates that's higher cooking art. That is complex from a computer scientist perspective. So this is great that you integrate it in a way that it's quite comprehensible even for non-computer scientists, especially non-security scientists, or some people with knowledge from that domain. So that's super.
Thanks.
Yes, bonus points for premise, of course. Bonus points also for PDF and the additional complexity of digital signatures. I was also very impressed with that. I think it's a feature that will be useful, especially for business archives. I was curious about your PDF. I was surprised that you use Vera PDF to validate plain PDF, and that the digital signed object is a PDF-E. And I was curious how it renders, but I'm sure that those are details that we can discuss during another tasting session, and I will hand to Kieran.
Yeah, beautiful user interface. I love that the premise event visualizations, making that stuff user-friendly for people, I think is very important.
Yeah.
But yeah, well done. I mean, I had never really looked into digital signatures much ever, so this was actually quite refreshing.
No,
to me.
it's digital signatures is something pretty new, especially from an archiving perspective, but it's very important, especially with all the legislations that are coming with EIDAS and the revision of EIDAS coming up. It's very important.
Yeah. Are there any questions for Michiel? No? Oh, yeah, we've got one.
Hi, I'm also a vendor, so I'm not trying to steal your information, but I'm quite curious, because we've also implemented the validation of the digital signature for same reasons. But I'm curious to know if you've implemented something from scratch, or are you using an actual library, or what's behind it?
For the validation itself, yeah, so we have our services set up for really doing the validations, and we also offer them actually as a service for archives that already have quite a lot and just want to do the validations or the timestamping or those kind of things.
Yeah, our platform is completely API based, and the user interface calls them and implements them as plugins. But we can complement existing archives with services that they need as APIs. Thank you.
Mention of an API, and it's another few bonus points there.
Oh.
Any other questions? Yeah, there.
Well, we've been lucky or unlucky enough to have been confronted with the same problems with digital signatures. One thing which I don't think you touched, but which we faced at the time, is how do we make sure that after migrations happen in digital preservation, we can still guarantee that our migrated file is still valid and actually legally still equivalent and signed, because we don't have access to the original signature anymore. We can't sign the, especially we are working as a service, we cannot sign on behalf of a partner. So how do you deal with that?
Digital migrations, if you change the file format, you change the checksums, and all signatures are invalid. So there's not really an option for that, except for keeping really the original and being able to prove that. But then you also need to be able to prove that your migration, your new representation is exactly the same as the previous one, and there's no real way to do that.
That's why you need a certification.
Yeah.
One very quick question also to the certificates. Do you also archive the certificate chain, the public one?
So that's actually all part of that archive of that validation report.
So they will be packaged.
So it's all in there because indeed, every item in there can expire at some point.
Yes.
Even if I sign a document with my EID, if I go half an hour later to the police and I say it's stolen, then they block the whole signature on it, and from that point on, nothing is valid anymore that I signed.
Yeah, sure, but at least you store the original certificates, the public ones, and the complete chain.
Validation report, so yeah, of course I show the visual version, but the validation report, there's a technical version of it that keeps the whole chain with all the proofs of the full chain that were there.
So we're going to introduce our next speaker now, which is SCAT.
It's Viv.
There we go.
While I get this organised, I would just mention that this is a complete change of pace, change of paradigm. Some of you may like it, some maybe not. We'll see. Okay, we're going. Right, I want to start here. Get my notes so I can remember all the points, because there are a lot. There are many valid use cases relating to digital preservation, and I've enjoyed the conference and being exposed to them. The case that I represent is that of what in England and Wales used to be known as County Record Office. The Archives Service is a memory institution established as part of local government. The core mission of the archive is to organise and keep the stuff that it receives safe by maintaining a chain of custody when preserving an original document. The document here is defined very broadly, anything that contains information. The archive is part of a heritage or memory ecosystem that includes many other specialisms, such as conservators, paleographers, and records managers. SCAT, a recursive acronym for Scatter's Curation and Trust, is our attempt to fulfill our archival mission in respect of born digital material. SCAT is a work in progress. It is a cross-platform, open source desktop tool and is currently being user tested. The approach is parsimonious, hat-tipped to Tim Gollins. The key feature is the operational Fixity Digest database, which is populated by the archive and, importantly, remains in the archive's custody. The work is also predicated on the empirical evidence that only about 80% of our collections are ever accessed, and most not for some decades in the future. I intend firstly to demonstrate accession, the ISADG provenance catalogue, which is what that thing is, and creating an AIP. Later, I can drill down as much as you like. I would mention that the tool is also designed for the smallest community archive. Right, accession. Well, this is the bit, this is kind of turning the oven on and the bits that got missed out. So, accession form. Everything that comes into the archive is supported by some paperwork. This provides not only information to us, so we can, for example, check that the document being offered to us falls within our scope of our collections policy, but also provides a receipt back to whoever it is that's donating or depositing the material. And we check various things in here, like, for instance, the copyright of the material that's being donated. I'd have also appreciated if the pantry could have provided some checksums of the stuff that's being downloaded, so that I could evidence that I actually got what was intended to be offered. And in fact, one of the downloads I could never get to succeed. And that is actually mentioned in the catalogue. So what happens is that it goes in the catalogue. And here we have the ISD entry, and what we're looking at the collection level is all this stuff, which is the archival description of the material, the pantry. And it contains 15 items, which we've got there, and which we will have a look at in a moment. But I'm still attempting to demonstrate accession, so I'm going to go into the tool, scan, and I'm going to start that up. And this is the tool which the archivist is presented with. And you see they can do their various things here. One of them is to create a package. And to do that, we need to add some payload. And having done some trials, I happen to know that we've got some here. So this is where I put the stuff that I downloaded from the pantry. So all of this is happening live. Okay, so that's the iPres 2015 dataset. And oh, I got that wrong. Okay. I'm going to abandon that and start again. Right. And payload. And to keep the presentation short. Okay, that's better. Okay, so I've added that iPres dataset as a folder, and we need to describe it. I'll talk about what the adjunct stuff is when we get to the other end. The package description I need here, and for speed, I'm just going to fill this out with stuff. What we would normally be doing here is a cut and paste from the information that we've got there. But I'm just going to skip that in the cause of being expeditious. So we save that. Save that. So what's happening now is that the tool is working behind the scenes and has created an AIP. It's a double bagged bag, so hat tip to Library of Congress for that. And the inner bag is encrypted by GPG, and it's AES-256 encryption. Okay, so that's created the AIP. I'll skip over actually drilling down in that, but I'll do the next thing, which is deposit the package. And this is reaching out to our storage provider. And so they are asking now for where to put or where to get the AIP from, and that's in the local AIP store. That thing that you see there is the AIP, so we upload that now, and that is all happening. It will in a minute upload selected. So that's happening now. So that's the upload. Oh, we appear to have managed okay. And there's a whole load of stuff here for those that are really, really interested. And if we go back to the tool, where we've got everything is okay. So that's taken the AIP that we've created, that I showed you how the archivist would do that, and it's uploaded it, and from here you can see that it's done a whole load of stuff, It's deposited it in AWS and Azure, and it's computed the fix of the package that it's received. And what happens at a later stage is that the storage fixity manager reports back to the archives what the fixity was of what it received, and the archive, the tool, can then compare that with the fixity of the package that was created when the package was created. And those two, of course, have got a match. Okay, so moving quickly on, the other thing that we might want to do is, I just want to shut all this down. Okay, the other thing that we might want to do in the archive, obviously, is request a package. And here we can copy from the details that we've got in our catalogue, ISDJ catalogue. We can copy that. You can put that in here, nearly there. We copy that and we get that from fixity storage, sign in again. Okay, and that's the one that we want. So here we go. Now, can you see now that we've requested that package UUID from fixity managed storage? We've completed the download, we've checked it against our operational fixity database, and it checks out. Good news. And we've done some baggage validation, and that's okay. And it's read the outer bag, and it's told us what the thing is, and it's given us access information, and so we're good to go. So that's the complete workload process. There you go.
That was lovely. It looked like you actually loaded the entire thing into the live catalogue.
Well, no. The only thing that was pre-prepared was the catalogue. The catalogue entries here, because I don't have write access. So credit to Claire Collins, my co-author of the paper tomorrow, who's a professional archivist and is the collections development manager at the Archives in Gloucestershire.
Bonus points as well. I think it's the first time we heard ISA-G and accessioning today, more than likely.
Also say that the monitoring report that we get back is premise.
So yeah, thank you very much. I think this is the perfect example of a excellent food truck dish, where you go up to a food truck, you're not sure what you're going to expect, and then the food just blows you away. You have so many very, very good things in there. I love the fact that you're targeting the smallest of the community archives, as you say. It looks like they should easily understand this tool and be able to use it, and thank you very much.
Pleasure.
Yeah, I love the simplicity of the interface as well. It was very, like, the overview was very good. Yeah, thank you.
Great presentation. So, great tool, great workflow. I think it's seldom, and I find it refreshing that there are tools tailored to small archives, which can be customized to their specific needs. So you don't need everything that, I don't know, the big suites all deliver, but you have your workflow and your tools as you need it, and as you also as you understand it, so that there's a good understanding of the whole workflow and how it works behind the scenes. So this is great, I think.
Thank you. Are there any questions from the audience for Viv?
I am going to do the dreadful thing of making a comment. What I really like about what you're presenting there is you've taken the workflow that Gloucestershire Archives uses, Gloucestershire Heritage uses for its paper materials, and you've essentially implemented it for digital. So you've got, it's clear to me that you've got one catalogue, you haven't got two catalogues. You've got a basic process, a basic understanding of the flow of material into the archive, which is uniform across your formats. And that's really quite rare, and is something that is to be commended.
Thank you, Tim.
Double bag.
Yeah.
Yeah. What? And with an encrypted bag inside a bag.
Yeah.
What drove that decision?
Okay. Well, there's 100 things I've had to skip over. Amongst other things, we deal with closed records and sensitive records. We are really quite shocked by the sector's drive to publish and to take anything that's digital, drill down, index everything that's possibly indexable, and make it available to the public. Now, there are curation cases, and if you look at, for example, the way that TNA handles the Victorian census material, there are good curation cases for why one might want to do that sort of thing. Now, this sort of brings some of the differences between archival practice and library practice into stark relief. We see the prime mission, the goal, to be able to prove that what we took in over the threshold is what we're producing to a user in decades, centuries hence. That's the job. Now, doing all sorts of fancy things with that material, in principle, is no different to all the fancy things that medievalists and paleographers do to medieval charters. I'm not a paleographer. I can access this stuff. It can be presented to me in the reading room, but I can't make any sense of it at all. I need specialist help now, centuries after the stuff was produced, in order to access it. And we see that happening with digital material as well. In 100 years' time, all the emulation tools and all the other stuff that's been the mainstay of the conference will have evolved, and specialists will be using, if you like, the emulation du jour to read the material that we've kept safe for a century and can prove that it's safe. So that's kind of what the relationship is. Does that kind of address the points that you were making? Thank you.
Any other questions?
Can I ask a question of the audience? I had to move so fast that I didn't make the point that that I too make use of open source tools. We will be making all of this open source. The obstacle that we have at the moment is that we don't really understand which of very many open source licenses we ought to be providing. If anyone here has a view or a recommendation, if they could if they could email my colleague, Claire Collins, she's the corresponding author on our paper, and make the recommendation and provide an argument for why. Sir.
Just on that particular one, you might want to reach out to some of the guys at TNA, because They make use of, they're publishing a lot of their stuff as open source.
Yeah.
I think they use the Open Government license for that.
Right.
I might be wrong. It's not strictly speaking designed as a software license, but it works very well for public sector in the UK.
Thank you.
So you might want reach out to them. They're doing a lot of it. I don't know the details.
Thank you, Tim.
Oh, hello, David.
Yeah, so a recent TNX Exodus, so we were using OGL, but I think that there were some incompatibilities with some of the licenses, some more recent software projects that they've published open source, not we anymore, are now done under MIT.
Yes, it's on our list. Thank you.
I've used MIT before, but just because I saw other people using it, I've no argument.
Thank you very much. And another round of applause for Viv. Giel didn't get a spoon. Oh my.
Oh, thank you.
Okay, we forgot to give one spoon. Well. With that, thank you very much for attending the 3 bake-off sessions. I hope you enjoyed them. If you do and would like to see them brought back to iPres, please say so loud and clear. Tracy Pop is in the audience, who's co-organizing the iPres next year. And also let us know what we can improve about the format, what you liked, what you didn't like. And with that, thank you and see you at the reception later. And please, before you go, feel free to hang out here, eat some of that lovely cake. It needs to be eaten. Yes, thank you.